So another example on integration by parts. So you've got integral of x squared e to the power x dx. Again, going back to our initial questions on when do we use integration by parts, it's good to see that this is an appropriate place to apply integration by parts. You've got two functions that are multiplied to each other. To integrate that, we use integration by parts. And again, the formula, I normally like to write the formula, which is u integral of u dv is equal to uv minus integral of v du. So one of them becomes u, one of them becomes dv. At this stage, up to here in this question, I think we can just decide on whichever one we want to make the u and dv. There is a method you will see in the next question that will help you decide which particular one you should make your u and dv. But for this case, we'll go with u equal to x squared, okay, and your dv to be equal to e to the power x. Very similar to question number 1, we differentiate this, so your du by dx is equal to 2x, and we are interested in finding du, so rearrange this. So du is equal to 2x dx. Okay, dv, which is the derivative of v, is equal to e to the power x. So to find v, we have to integrate e to the power x, and v equals e to the power x. Again, we're not worrying about the plus c's, we'll put it right at the end. So far, if you have a look at this, I'll go and put everything in the formula. The integral of x squared e to the power x dx is equal to uv x squared e to the power x minus integral of v, which is e to the power x, du, which is 2x dx. Okay, running out of space here, but we'll do it on the next page. So I've rewritten the question here. So far this is what we've come up with. Integral of x squared e to the power x is equal to x squared e to the power x integral of this. So we've already applied integration by parts once, and this is what we come up with. So we'll try and simplify this expression here. Okay, so this is equal to x squared e to the power x. That 2 is a constant, so it can come outside the integral sign. And I'm left with x e to the power x dx. Now if you look at this integral here, okay, I'll probably, okay, that bit, you will see that this is again a product, or it is two functions multiplied together, and I'm finding the integral. So you'll have to apply integration by parts to this again. Okay, so we'll try and do it here. So we're interested in x ex dx, the integral of this. Again, you can go u is equal to x. We'll go dv is equal to e to the power x dx. So we're just integrating this bit here. Du by dx will be equal to 1. I am interested in du, so I'll go du is equal to dx, because that dx goes here. 1 times dx is just dx. Again, same thing. This is dv. I am interested in finding v, so therefore I have to integrate this function. And the integral of e to the power x is just e to the power x. Okay. So going back to this here, that becomes u times v, okay, which is the formula for integration by parts. So uv x times e to the power x minus the integral of, okay, so I've got this here on the right hand side, uv minus integral of v du. you'll see that this integral here simplifies now. So I've got x e to the power x minus the integral of e to the power x is just e to the power x. Okay, so this here is the integral of this, which goes in here. Okay, so I'll write the whole thing. The integral of x squared e to the power x dx is equal to this minus 2 multiplied by the integral of this. And the integral of that, which is here, is all of that. And then I can put the plus c in here.